Hi students, in today's video we take up a new question from exercise 22. This is an unsolved question, question number 4 from Ship Stability to Captain Subramaniam's book, Trim Type A Problems. So the question is, a ship is floating at an even keel draft of 10.2 meters. So even keel draft means the forward and the aft draft is the same. The TPC is 30, MCTC is 320, HF is 2.5 meter aft, length between perpendicular is 180 meters. On this ship, a heavy 240 tons of heavy lift is loaded on deck, 40 meters abaft of the center of flotation. You have to find the new drafts at the forward and aft perpendiculars. Pause the video here. Read the question very carefully, and before you watch my solution, try to draw a diagram to just be able to visualize or conceptualize what is happening in this question. Alright, I will draw the diagram now just for me to be able to understand what is going on in this question. So the vessel is on even keel, that means the forward and the aft draft is the same. So I will draw at water level at the same level. So both the drafts 10.2 meters forward and aft is the same. All right. This is 10.2. This is 10.2 meters as well. And then we have the ship's length is 180 meters. The total length of the vessel between the perpendiculars is 180 meters. Now remember, this is the forward part of the vessel and this is the aft part of the vessel. Then I draw midship denoted by the letter H. So that means if this is midship, then each half of the vessel is half of the length between perpendicular. In this case, half of 180 meters is 90 meters. Center of flotation is 2.5 meters abaft of the center of midship. So I will call it F here. This is 2.5 meters abaft of the midship. And where did we load the cargo? We loaded the cargo somewhere on deck. So I will just use a different color of pen here. If I can use red maybe. So we loaded the cargo somewhere here. This cargo here, 40 meters abaft of the center of flotation. So 40 meters abaft of the center of flotation is its center of gravity. So the center of gravity here, let's call it G, is 40 meters abaft of center of flotation. And we loaded 240 tons of cargo. So that means vessel has become heavier now. All right. Then rest of the values is TPC equals 30, MCTC equals 320. All right. So the first thing I will do is overall change in the trim equals trimming moment, or we also sometimes write it as TM, trimming moment, divided by MCTC. So what is trimming moment? Trimming moment is nothing but weight loaded, discharged or shifted multiplied by the distance from the center of flotation and the center of gravity. So the distance G to F. So G to F. G to F is given to you already. 40 meters abaft of center of flotation. It is already given to you. Right? So you can say G to F divided by MCTC. So we know all the three values. Yes, we know. So TC equals 240 tons of cargo loaded multiplied by G to F is 40 meters. This is ton, this is meter. And MCTC is 320. In this case, you will get it. Answer is 30 centimeters. All right. Put the values in the calculator. You will get 30 centimeters. We know the overall change in the trim. Then change in the trim aft is given by the formula TC, which you have just calculated, multiplied by AF. AF is nothing but the longitudinal distance from the center of flotation to the aft perpendicular. So this distance here. All right, what is this distance here? So if from aft perpendicular to midship is 90 meters and center of flotation is 2.5 meters from the midship, that means this distance here from aft perpendicular, let's call it A to F. A to F is nothing but 90 minus 2.5. which is equal to 87.5 meters. All right, so from aft perpendicular to midship is 90 meters. Center of flotation is 2.5 meters abaft of center of midship. So from aft perpendicular to center of flotation is 90 minus 2.5 meters, 87.5 meters, divided by length between perpendicular, which you already know is 180. So how do I write this? 30 centimeters multiplied by 87.5, which is AF, divided by 180. This gives you the answer 14.6 centimeters. All right, and then we have TF, change in the trim forward, which is nothing but TC, overall change in the trim, minus O, change in the trim aft. So 30 centimeters minus 14.6 centimeters, which is equal to 15.4 centimeters. At this stage, if you want, you can also convert it into meters by dividing each value by 100. So 30 divided by 100 is 0.30 meters. 14.6 divided by 100 is 0.146 meters. And 15.4 centimeters divided by 100 is 0.154 meters. So we convert it into meters because we will now be applying these corrections to the drafts, and the drafts are given to us in meters. That's how the I think the examiner will want the answers as well. Now remember, one last correction you have to apply is the overall or mean sinkage of the vessel. What is mean sinkage? Now mean sinkage will happen because you have loaded something, right? So you have loaded 240 tons of cargo. Although you have loaded it in the aft part, and the aft part will become much heavier than the forward part, overall the vessel will sink as well because you have added some weight to the vessel. So overall also the vessel will become heavier. So how do you calculate this mean sinkage? This mean sinkage can be calculated by the formula weight loaded or discharged divided by TPC. So in this case it is 240 tons of weight loaded divided by 30 is the TPC, and the answer you will get is in 8 centimeters, or you can call it 0.080 meters. All right, now let's write the drafts forward and aft. So initial drafts forward and aft, let's start with initial drafts. The drafts that we started off with was even keel, 10.2 meters, 10.2 meters, right? Everything is in meters, remember. Add the sinkage. So the mean sinkage will apply to both forward and aft draft of the vessel because of the vessel becoming overall heavier. So 0.080, and same correction will be applied aft as well. So the draft will become 10.280, and this case also 10.280. However, you will apply trim forward and change in the trim aft. Now, how will you apply these corrections? Now, because I told you, you have added the weight aft part of the vessel. So aft part becomes heavier and sinks down. That means aft draft will increase. And because aft draft becomes heavier, forward draft becomes lighter and the vessel comes up. So the forward draft will become lesser. So therefore, change in the trim aft will be a positive correction, and change in the trim forward will be a negative because forward part is becoming lighter and coming out. So just put the values of TF and TA. So here it will become 0.154 and this will become 0.146. Subtract the two, 10.126 meters, and this is 10.426 meters. So these are the final drafts forward and after corrections have been applied. All right. That's pretty much it. That's the answer. So let me know, guys, if you have any doubts. Otherwise, I'll see you soon with my next video. Watch all the videos of this particular exercise to get a good understanding of these type of problems. Because even if the numbers are different in the questions posed to you in the exam, you can still solve it. Thank you.